Hello. Today we're going to be talking about a system of equations, and a system of equations, that's going to be a set of equations, two or more, and they all contain the same variables. So a lot of times you'll see two lines, and they're both going to have an x and a y variable here. So when we find or solve a system of equations, we want to find that one xy combination that works for both of these equations. Okay, so the solution for these systems of equations is wherever their graphs will intersect. So we have a couple options. If I draw my lines, so here's one line and here's another. If they intersect just like normal, so that right there would be their solution. This is what it looks like when it has one solution. Okay, I can draw them a different way so that here's one and here's another. So these lines are parallel, meaning they have the same slope. And since they don't cross at all, this has no solutions. Okay, and then your other option here is if you have one line drawn in, and then the other line sits right on top. So these are the same equation. So they're they're two different equations, I guess, but the graph is the same. So this is what it looks like when there are infinitely many solutions. Okay, so let's go ahead and actually solve one. Here's a system of equations. We have y equals negative 2x plus 1 and y equals 3x plus 6, and we want to solve this by graphing. So if I look at this first equation, y equals negative 2x plus 1, well, my y-intercept is 1, so I'm going to start at positive 1 on the y-axis. Then I'm going to do a slope of negative 2. That's negative 2 over 1. So my rise is negative 2, so that's down 2. And I'm going to go right 1, and I can do this repeatedly. Okay, so that's what that looks like. All right, let's look at the other one. If I have y equals 3x plus 6, my y-intercept is 6, so I'll go up 1, 2, 3, 4, 5, 6. There we are. And then my slope is 3, and that's 3 over 1. So I can go up 3 and right 1, but I'm going to run out of space up there. So I can also go down 3 and left 1, and I can do that repeatedly. So that's what this looks like. All right, so my two lines are graphed. The solution is that one ordered pair that's true for both of them that I just bolded in black. So the actual solution is the ordered pair negative 1, comma 3. And what that's telling you is that if you put in negative 1 for x and 3 for y in both of these equations, it should be true. So let's test that out. If I take the top equation, I'm going to have 3 equals negative 2 times negative 1 plus 1. So I get 3 equals positive 2 plus 1. So that checks out. 2 plus 1 is indeed 3. If I take the second equation, I'll put 3 in for y. I'll put negative 1 for x. So 3 equals, and I get negative 3 plus 6. That also checks out. Negative 3 plus 6, or 6 minus 3, is indeed 3. So that is true. And we are done.